Okay, good morning, everyone, and hope everyone is doing well. Today we'll begin lesson two, um, Pythagorean theorem, and that's on page 3 in your booklet. Now, just the main goal for today's lesson is to calculate the measurement of the third side of a right triangle using the Pythagorean theorem. Now, just look at a review on what is a right triangle. As you can recall, a triangle consists of three sides. All triangles, and earlier we said there are three types of triangle other than the right angle triangle. We said the first one is the right angle triangle, which we know it has 90 degrees as one of the angles. The other three are a scalene triangle. Scaling, all of the angles are not equal. They have no equal angles and no equal sides. Isosceles triangles, we said there are two equal angles, and the base angles are the equal angles, and two equal sides. The third triangle, apart from the right angle triangle, is what we call the equilateral triangle. All angles and all sides are equal. Now, in this case, the right angle triangle, which is the fourth triangle, only one of the angles is 90 degrees. And it's normally indicated by this square beside it here. And it's a symbol for right angle. So anytime you see this angle inside of a triangle, it indicates that's 90 degrees. So since we learned from lesson 1, the sum of the angles of a right angle or any triangle is 180 degrees, it means that the other two angles, some of the other two angles here are 90 degrees, so equals 180. So this is a right angle triangle. We have you have two sides, and these two sides are perpendicular, and perpendicular means they're 90 degrees. Right. And the small box is placed in here to indicate that's 90 degrees. So this is a right angle triangle. So we put right angle triangle. Now, since these three angles, if we would call this angle A, angle B, and angle C. So these three angles, the sum of the angles, the angle A plus angle B plus angle C, they're all equal to 180 degrees. So let's say angle B is equal to 90 degrees. So therefore, angle A plus angle C will also be 90 degrees. We don't know what angle A is or angle C, but later on we'll find out how we can calculate those two angles. Okay, so here, why is it impossible to have more than one right angle in a triangle? Now, if you were to do that, if you were to make a triangle, both of them angles 90 degrees, it means they'd be equal to 180. And since any triangle has three angles, you'll actually have no angles. They'll be beside each other. So you will have a triangle with only two angles, and that's not a triangle. So we can say here, because it will be a figure where two angles equal 180 degrees. Okay, and the triangle has three angles. So therefore, it is not possible. So let's look at how to label different triangles. Now, as I mentioned before, triangles basically have three sides. And to make it easier for us to describe, each side is given a separate name. The first one we look at is the side opposite the 90. This is your 90 degrees. The side opposite it is called the hypotenuse. So it is the longest side. We can think of this as two legs over here, and the side opposite the two legs, you can say it's the hypotenuse, but more specifically, the side opposite the 90 degrees is called the hypotenuse. So this will be the hypotenuse. We can label it here. So that's how you spell that wonderful word, hypotenuse. So this will be a hypotenuse. So this side here is opposite the 90 degrees. So this will be a hypotenuse. Now, it just happened to both these sides here are high. So this one, so we can put an arrow here, that's a hypotenuse, that's a hypotenuse. I ran out of space here. And this will be the hypotenuse. We can write that here. And finally, we have the hypotenuse here. So that's labeling the sides of a triangle. Now, the other two sides we'll look at also have names. And as you look at this one here, the hypotenuse is always a side opposite your 90-degree angle. So what do we call these other two sides? Well, that's, if you turn to the next page, we'll look at those. Now, it's all this, the whole idea of how to calculate the sides of an angles of a right angle triangle. This came from this a Greek philosopher by the name of Pythagorean, and who has been given credit for discovering the squares of the sides of a right triangle add up to the squares of the hypotenuse. So, for example, here, if you have any right angle triangle and you measure the sides, the two legs, and you square them. In other words, find the number of squares if you were to make a square on both sides here. And you add the number of squares in these squares, certainly a lot of squares, it will be equal to the square on the side of the hypotenuse. So essentially, we're looking at the three sides. Now, let's look at what the different sides are called. So previously, if we go back to the previous page, we have these triangles here. Oops. Here. Now, the other two sides, we can label these. This could be the opposite. Now, why is it called the opposite? Because let's name this, we don't have an angle here. Let's say there's 60 degrees here. Now, this will be the opposite side. Because I'm referring to this angle here. So this side is opposite this angle. The other side will we call the adjacent. So the side opposite the 90 degrees is the hypotenuse. The side that's opposite the angle that's given is called opposite. Now, later on, we'll find out that the opposite side could be interchangeable depending on what angle is given. So if I were to label this one over here, we can say, if I name this as my angle, let's call this angle 20 degrees, this will be the opposite side. and this will be the adjacent side. Now, sometimes, as you realize, hypotenuse, opposite, and adjacent seems to be a lot to write. So we normally abbreviate them just to make life easier when we're writing it. We can say HYP is equal to the hypotenuse. ADJ equals the adjacent. And OPP equals opposite. So that explains or describes the size of a right angled triangle. So let's go back to our page we were at before, and we go back to the Pythagoras theorem. Right? So the Pythagoras theorem said that if you have a right angled triangle, like the one we have here, so this is 90 degrees, that's a hypotenuse, and we can call the side A and B. We know they could be called adjacent and opposite, but for now we'll call them side A and side B and hypotenuse. So generally they refer to the hypotenuse as side C, but you can label it, give it any other name you want. Oops, align this properly. So to label it, so we call this hypotenuse, we call this A and B. So the Pythagorean theorem says that if you have the square of the adjacent side, and you have the square of the opposite side, we call it opposite, the sum of these two squares equal to the square of the hypotenuse. And it's indicated like this. So you have A squared plus B squared equals C squared. So A squared plus B squared equals C squared. Or another way of writing side square plus side square is equal to hypotenuse square. So this is known as the Pythagorean theorem. Okay. So let's look at some example on how to calculate missing sides. Okay. So here we go for missing side. Now here we're going to use, first thing you want to do is to label the sides of the right angle triangle. So we label this as C, and it doesn't matter which one of these you can label as A and B, but we'll follow what we have at the top initially and label this, we call this side A, and this is side B. So what do we want to find? So we want to find the hypotenuse. So we know from our formula here, A squared plus B squared equals C squared. So what I like to do is to write down what's given. So what's given? So given, you're given A, which is 8.7 centimeters. You're given B, which is 6.5 centimeters. And you're given, but you're not given, you're asked to find C. So now what I do, I'm going to substitute what's given into my equation, the Pythagorean theorem, and solve for C. So here we go. We put my A is 8.7 plus 6.5 square equals C squared. Now, this is where you will use your calculator. Now, I'm going to use a graphing calculator to punch this into my, so 8.7 square, so I put 8.7 square, the square button. Now you can do it separately. You can say, okay, I'm going to make 8.7 squared, and I do the whole thing, but I'm going to do it separately for now. 8.7 squared, and I press the enter button. So this is 75.69 plus 6.5 squared. This worked out to be 42.25 equals c squared. So I'm going to add these two, the sum of those. So 42 plus, let me add these two up. So we have 42 plus 75.69 gives me 117.94 equals c squared. Now to solve for c, I have to square both sides, the square root. So c is equal to the square root of 117.94. I go into my wonderful calculator, and I say second, get my square root sign. I can actually input this directly, but for my calculator, it's saved. So I press answer, and it gives me 10.6. 10.86. And that will be in centimeters. So C is equal to 10.86. Okay, let's try one more example. So here we have a triangle that doesn't look like the one we just did. It's not nicely aligned. It's kind of a twisted of an angle. But that should not confuse you, because in labeling a side, so we can label this, we know this is hypotenuse because it is opposite the right angle. So we know this, we label this as C. It's the hypotenuse. Remember, try to label your hypotenuse as C, and the other two sides would be A and B. So it is A and B. Then we write our formula back. We have our formula is A squared plus B squared equals C squared. So A is 7.6 squared plus 13.7 squared equals C squared. Now, by the way, some people prefer to have the unknown on the left, and you can do that. It's easy. So if you're not happy with having it the unknown on the right, you can also leave it over here. It's the same thing because they're equal. So now I have C squared is equal to, and I'll go to my wonderful calculator again, and I'm going to let the calculator do some work. So look up here, okay. So 7.6 squared. It'll give me enter 57.76. Then I have 13.3.7 squared. That'll give me 187.69. So 187.69. I'll add those, so plus 57.76. Give me a sum of 245 C squared. Now I'm going to go C now is a square root 245.45. So I go to my trusted calculator, and I'm going to do my square root. Now your calculator might be different what you're using right now, but this is what I have right now to work with. So if you have a graphic calculator, you can do the same process. So my answer is now C is 15.6. Now notice in your calculus, this is repeating decimals here. So we can round up to 2 decimal places. So since the digit to the right is greater than 5, we can run the 6 to 7. So we say this is 7 centimeters. Oh, it's kilometers. So don't forget your unit. You always write down your unit. So the length of this side is 15.67 kilometers. So your task next is to complete assignment on the Pythagorean theorem. So there are 1, 2, 3, 4, there are 8 questions. So that's it for today. Tomorrow, we will look at the next lesson using the trig ratios to find side length.